Hello, in this video I will do a short review on test 1. Basically, I will solve all problems in test 1, okay? The first question, they ask you to find the area of the region. About it, by the graph of the function y equal to 4 minus x over square root of 4 minus x squared. The x-axis, x equal to 0 and x equal to 1. So they don't give us any graph, but we have to make sure that the graph of this function is above or under the x-axis, or maybe the function has some x-intercept, right, in this interval 0 and 1. We are lucky because in this case, the function is always positive. I have to mention one thing, right? The function 4 minus x over square root of 4 minus x squared is positive on 0 and 1. It's obvious because 4 minus x is always positive, right, on this interval. So that means the graph of the function is above the x-axis. Is above the x-axis. So I might have something like this, I don't know exactly, but you plug 0 into the function, you get to 4 over 2, right? So that means the function value is 2, and you plug 1 into the function, you get, let's say, f of 0 is 4 over 2 is 2, f of 1 is 4 minus 1 over square root of 4 minus 1 is square root of 3, right? So square root of 3 less than 2. So I have something like this. Okay, this is 1. The graph look like this, and this is the region. So we are good. The area is equal to definite integral from 0 to 1 of the function 4 minus x over 4 minus x squared dx, right? We know about this function already in the practice test. We need to break this function into 2. So I have 4 times dx over square root of 4 minus x squared. Another one is minus integral from 0 to 1 x dx over square root of 4 minus x squared, right? The first integral is x sine of x over 2 because a is 2, okay? Evaluated from 0 to 1. And the second one, we need to do substitution. Let me solve that separately in here, and then we'll plug the number into this position, okay? So let's solve this integral. We put u equal to 4 minus x squared, because you have combination x dx and x squared right here. From here you get du is negative 2x dx, or x dx is equal to du over negative 2, right? So I can rewrite. I just need to find antiderivative first, okay? So I rewrite my integral, that is negative 1 over 2 du over square root of u. And that is negative 1 over 2 u to negative 1 over 2 du, right? Because you rewrite square root is power 1 over 2. 1 divided by 1 over u of 1 over 2 would be u to negative 1 over 2. And you use the power rule. You have negative 1 over 2 plus 1 divided by negative 1 over 2 plus 1. Plus c, that's 5. So you have negative 1 half in here with 1 half in here. That will be cancelled out, but you still have negative. Then you have negative square u to 1 half plus c. Finally get negative 4 minus x squared 1 half plus c. So that is antiderivative, right? And now if you want to find, the definite integral, you need to plug 0 and 1 into this function. So this integral is equal to, I write negative, but you have negative right here, so I would write positive, okay? Positive 4 minus x squared to 1.5, evaluated from 0 to 1. And then you plug, numbers into these functions. You get the first one is 4x psi of 1.5, okay, minus x psi of 0. The second one is square root of 4 minus 1 square minus square root of 4 minus 0 square. So basically this is square root of 3 minus 2, right? And in here you get 4 times x psi of 1/2. You may use calculator, but x psi of 0 is 0. X psi of 1/2 should be pi over 6. So I have 4 times pi over 6 plus all this. So I get 2 pi over 3 plus square root of 3 minus 2. That is the answer for the first question. All right, let's move to the second one. We need to evaluate indefinite integral dx over 9 plus 4x squared. This is almost, I would say, free, right? 30 boys. No, 50. Yeah, you have two integrals there. So when you see this combination here, you would think about arctangent, right? Arctangent. But you need to change the function a little bit, because some students didn't change that. I would write like this, right? If you want, you may factor, you might take 1/4 out. I write 1/4 and then dx 9 over 4 plus x squared. You see, because you have a squared plus x squared. If you want to use a squared plus u squared, you need to change the variable. You need to do substitution. If you don't want to change, you might take 1/4 out, means divide, this guy, right? Just by 4. So basically, from here, you might use the formula right away, where a is equal to 3 over 2. So that is 1/4 and then 1 over a, which is 1 over 3 over 2, arctangent of x over a, x divided by 3 over 2 plus c. So the answer is, you flip this, you get 1 over 6. All right, 4 times 3, arctangent of 2x over 3 plus c. That is 1 over 6, arctangent of 2x over 3 plus c. Okay. Next question. C. B. You need to find integral e to 2x plus e to negative 2x. So for such integral, you have e to 2x and e to negative 2x. I would change, right, like this, dx over e to 2x plus 1 over e to 2x. We simplify that first. And then from here I get, e to 2x dx over e to 4x plus 1. Does that make sense? So please check that carefully. Okay, and from here I can, since I see e to 2x dx, and here I have e to 4x, right? So I put u equal to e to 2x. I put u equal to e to 2x. From here I get du is 2 e to x dx. E to x times derivative of 2x, so that is 2. From here I get e to x dx equal to du over 2. And my integral is equal to 1/2 du over u squared plus 1. And that's what we know, right? This is 1/2 arctangent of u plus c. And u is e to 2x, so I have 1/2 arctangent e to 2x plus c. That's it. Okay. Next question. We need to find the limit. X minus 1 to ln of x approaches 1 plus. So let's say this a, right? And when you plug 1 into the limit, you get 0 to infinity. We know that. We need to apply ln, right? And from here I get ln of a is equal to limit of ln of, let me write this, when x approaches 1 plus. I don't see any correct solution on this problem. So I will take ln out right here. So I get limit of what? ln of x times ln of x minus 1. X approaches 1 plus. Okay, so we have ln, you know, when you plug 1 into the function, you get 0, infinity. So we might choose, you know, two ways. But I choose the following way. I write limit of ln of, you know, x minus 1, and then 1 over ln of x in here. X approaches 1 plus. Now let me differentiate the top and the bottom. I have ln of x minus 1 derivative divided by, I write ln of x negative 1 and then derivative is 1 over x minus 1 divided by negative ln of x negative 2 times 1 over x. Is it correct? By the chain rule. So this is, I write x over x minus 1 with the negative in here, ln of x to negative 2. Let me change this, right? Okay, so we have ln of x to negative 2. So basically on the top I have 1 over x minus 1. In here I bring negative to this. I have 1 over x ln of x square. Does that make sense? So basically that is x ln of x square divided by x minus 1. Okay, so you plug 1 into this function, you get 1 times 0 square, negative in here, 1 minus 1, so you have to form 0 over 0. That means you still may need to differentiate. Okay, so I will consider the following limit. The limit of x ln of x square derivative over x minus 1 derivative when x approaches 1 from the right. Okay, so on the top I need to use the product rule. Here I just have 1. I mentioned this several times. This is not the quotient rule. Okay, this is quotient of derivatives, not the quotient rule, because we want to use L'Hopital rule. So I use the product rule. X derivative is 1. I don't write it. I have ln square and of x square. The second one is plus x. Derivative of ln x square is 2 times ln of x times derivative of ln, which is 1 over x. Right? So from here you might simplify, you know, x with the x in here, right? The limit 1 is just, you know, just 1. I don't write it. I have negative in here, but that's fine, you know. We will remember this negative, okay? So the limit of ln square plus 2 ln of x when x approaches 1 from the right. And when you plug 1 into this function, you get 0, because ln of 1 is 0. Right? Perfect. So this limit is equal to 0. By the L'Hopital rule, the limit of the function without derivative in here and in here, that means this the limit of this function is also 0. Right? It's also 0. So I write like this. This approaches 0 as x approaches 1 from the right. But you know, this limit is 0. That means the limit of this function, this guy, right, when x approaches 1 from the right is 0. And the limit of this guy is 0. So that means the original, not the original one, but the limit right here equal to 0 by the L'Hopital rule. Does that make sense? So at the end, we arrive at ln of a is equal to 0. You see that? From here you get a equal to e to 0, which is equal to 1. Okay. Next problems is about differentiation rules. I think it's very easy. First one is y equal to ln 5 x over x squared plus 1. So, we need to simplify this function first, right? You have ln of 5, x in here, and then minus ln 5, x squared plus 1. And you apply the formula for the derivative. Y prime equal to 1 over x, right? And times ln of 5 minus 1 over x squared plus 1 times ln of 5. But in here, you need to multiply x squared plus 1 derivative, which is 2x. So I have 1 over x ln of 5 minus 2x over x squared plus 1 ln of 5. So that's the first problem. The second problem is square root of x squared minus 4 minus 2 x sine of x over 2. Okay, so again, we just need to apply formula, right? For the first one, we use the chain rule. I write this in the power form, x squared minus 4, 1/2, and then derivative. Here we already have formula, and that is 2 times, right? 1 over square root of 1 minus x over 2 square times x minus 2 derivative. So basically, this is 1 over 2 x squared minus 4 to negative 1 over 2 times 2x minus, so derivative of this guy is just 1/2. 1/2 with 2 will be cancelled out, so I will not write it. I write 1 over 1 minus x over 2 square. If I don't ask you to simplify, you don't have to. But in this case, you must simplify this and this. Does that make sense? All right, let's move to the last problem, which is, in my opinion, also easy because you just need to solve to show that on the unit circle. I don't ask you to find it. Of course, without they ask to find it, but as I mentioned, you just need to show on the unit circle. Does that make sense? So the unit circle, we need to draw it out. Okay, this is the unit circle. Here is the tangent. Tangent equal to -3. Arctangent -3. This is -1. So -3 should be somewhere right here. -2 and -3. I don't see any correct picture. So you connect that point with the origin. That is your arctangent, -3. And then in order to find cosine, so you need to draw the vertical line. So that is cosine of arctangent of -3. Yeah. For this, you get full credit. Okay. So I hope that the video is clear enough. If you have any questions, we can discuss with you on team or in the class.